I started reliability.org to create a community for engineers who care about building reliable systems, ones that are predictable, have low unexpected downtime, come up fast from failures, and have low performance jitter. It's a topic I've cared about for a long time. Part of the reason I created Shoreline, the startup I run. So what is reliability engineering? It starts by understanding that every part of your stack can and will fail, whether that's the network, the hardware, the software, or the services you depend upon. So the first question as you're trying to build a reliable system is to understand the failure rate of the stochastic noise level events that just happen. It's a probabilistic argument. The next question is to understand the failures that happen together, the ones that are correlated. The third question is to understand how long you have failures and how long you need to tolerate them. If S3 is down, maybe it comes up after an hour or two. So you need to tolerate that failure for that duration if you have a dependency on it. And so finally, how you tolerate those failures and build a fault tolerant system. Let me use an example. When I was at AWS building Aurora, the key issue for us was how to tolerate storage failures, because storage failures are high impact for customers, require a long recovery as you do point-in-time restore from a backup, and possibly result in loss of data. And at scale, there's an ever-present failure rate in the nodes you use, the drives, the network cards, everything. We dealt with that by using quorums. Using quorums, you can tolerate some percentage of the copies of data not being available. That deals with jitter, short-term loss of connectivity, as well as long-term loss of durability with one simple technique. It also helps you deal with correlated failures. In Aurora, we used a 4 out of 6 quorum because we wanted to tolerate our largest possible failure, an availability zone going down, perhaps forever, losing a couple of copies of data, and as well as the background noise failures that might happen alongside that. And then the next issue was ensuring these failures don't collect and accumulate over time. We use small segments of data that are quickly repairable so that the window of vulnerability isn't too long. There's a lot more to this sort of topic. It's super complex, but you get the sense of how it works. Understand the failure and their probability, understand how to tolerate them, and understand how to minimize the window of vulnerability. Actually, Shoreline has a part to play in this as well, because the faster you can automate the repair of the components and shift to other things if they're hard down for a long time, the smaller your window of vulnerability is as well. All of these things sort of play together. Join me on reliability.org to talk more.